Good morning, everybody, and welcome to Math with Mr. W. Today, we're going to be talking about scientific notation. Scientific notation. What's this all about? Well, scientists are always dealing with big numbers and very, very small numbers. And I have examples of both of these right here. The first one says 80 million. That's a big number. But mathematicians want to write it in a way so that it's easy to understand and work with. So we're going to use scientific notation. And another example here is, wow, tens, hundreds, thousands, 10,000s, 100,000s, millions. We have 35 millions. That's really, really tiny number. If something was broken up into a million parts and we're only going to look at 35 of them, that's a tiny amount of numbers. That's a tiny amount. So how can I write that so it's easy to understand? And you'll notice that I have these answers here. Well, how did I do that? Well, I look at where the decimal starts. And I'm going to move the decimal into a position so that the new number that's here, the 8, and here the 3.5, it has to be between 1 and 10, between 1 and 10, between 1 and 10. Okay? So here's an 8, here's 3.5. It's between 1 and 10. So the number in front has to be between 1 and 10. But now what happens is, if I'm going to make a big, large number here, like 80 million, and I'm going to move it all the way down, and now I'm going to call it 8, I have to multiply that by 10 to something to get back to what the real value is. So I have to count back each one of these spaces, which is a space of 10, which you've learned about over and over again. So we count the spaces, 1, 2, 3, 4, 5, 6, 7. So when I get my decimal back here, I moved back 7 spaces. And because I've made my number smaller, I have to make a positive 7 up here when I write 10 to the 7th. Okay, now, what happens when I have a little tiny number? Well, here it is, 35 millionths, a little tiny number. But I'm going to move this decimal until it gets to a place that's between 1 and 10. Well, if I'd only moved it this far, it would be 35 hundredths, and that's not between 1 and 10. If I went too far and went over here, it'd be 35. That's not between 1 and 10. This place, 3.5 or 3 and 5/10, is between 1 and 10. But now I've taken a very small number, 35 millionths, and I've made it into 3 and 5/10, which is much, much bigger. So I have to multiply that by 10 to a negative amount, which we've learned with exponents, it means it's dividing by. So we're dividing by instead of multiplying by. That's really what we're doing. This is 1 over 10 to the positive 5th. 1 over 10 to the positive 5th. So you have to kind of remember the difference between positive and negative exponents. So we end up with 3.5 times 10 to the negative 1, 2, 3, 4, 5, So we moved 1, 2, 3, 4, 5. We moved it 5 spaces, so we get 10 to the negative 5. So if you take any large number and we make it small, it's a positive exponent. And if we take any small number and we make it large, then our exponent is negative. Thanks for seeing us today, and see you next time when we talk a little bit about light years and how scientific notation makes the idea of a light year easy to understand. See you next time on Math with Mr. W.